All right, so thank you all very much. My name is Twyman Clements, and I am with SpaceTango, and we are a ISS National Lab and NASA implementation partner. And what we really focus on is enabling customers to use microgravity for research and manufacturing purposes. And so kind of the title of my talk is just an overview of who we are and what we do, is establishing new markets for research and manufacturing. And so that's really our focus, as we want to take the work that researchers like you all are doing and move and understand how microgravity could be a value add. And then potentially, if there is a manufacturing use case, scaling that on the space station and potentially past the space station. So what you're seeing here is one of our cube labs. You'll see a little bit about our product line and how we work together. This is one of our smaller ones here floating on the ISS. And you know, we're a company that's been around since 2014, but in terms of using the ISS, our first operational launch was in February of 2017. And in that time, we've flown over 80 payloads since then. And what you'll see is a wide variety of payloads, from material science work to education to studies in yeast, bacteria, all the way to complex biology like tissue engineering, tissue organ chips, brain organoids, stem cell work, a pretty wide variety. And so we're based in Lexington, Kentucky. We have a flight operations office in Houston, Texas, and a commercialization office in La Jolla, California. And then we use the launch site capability in preparation for launches at the Kennedy Space Center and NASA Wallops, depending on which vehicle we're riding on. So that's kind of who we are. And then so to get a look kind of a level deeper in terms of how we accomplish using microgravity in the ISS, we have these facilities, and you'll see what the actual experiments look like here in a second. We have a few different types of facilities. The first are the Tango Lab facilities that are permanently installed on the ISS, and then we have what's called our PAL facility, which stands for Powered Ascent Utility Locker. And the difference between the two on the left, Tango Lab 1 and 2, and PAL, from a networking and power capability, they're the exact same. But the one on the right, PAL, is built to run inside the launch vehicle for power when powered ascent is required for typically complex biology work. And so the cube labs are installed in there. You'll see what those look like in just a second. It's transferred from the vehicle onto the station and continues to run once power and data is connected. So it's a capability that allows us to gives us kind of a suite of capability that we can use. We're a full in-service provider from end to end. So we typically work with the customers to understand exactly what they want to accomplish in any of these variety of use cases, to develop our cube labs, exactly what needs to occur in them from an analytics standpoint, from a temperature control and environment standpoint. We build those, we test those with the customer. They're launched to the space station and then obviously plugged into our facilities on the ISS to operate. So this gives you a little bit more insight into exactly what all of this looks like. So you can see on the two left-hand side photos, those are cube labs that were developed. Those are plugged onto what we call payload cards, where we can attach multiple cube labs, and then those are installed into the Tango Lab facility in the third photo there. Once it's connected, once it's powered on, it's networked down to our ground stations in Lexington and in Houston, where we can then control the experiments. We can ensure that all the sensors, all the temperature control systems, all the cameras and everything are working, and we're pulling data down regularly, and then distribute that to our customers, online. So this gives a little bit more context in terms of since our start in February 2017, we've done 13 missions with, like I said, almost 80 different payloads, and some payloads have a few more experiments in them than others. So that's why our experiment total is a little higher. And like I said, done across a pretty wide variety of different types. So with some of my remaining time, just to walk through a little bit of kind of the different ones we've done. We've done quite a bit of work in plant research. both in terms of passive seed exposure to germination to full growth. One group we've worked with is actually Budweiser. That you can look up some of our work with them, as well as doing Arabidopsis, barley, and other plants. We've even tested aeroponic growth systems instead of using gels. That kind of removes us from requiring cold stowage requirements on the space station, and have done these from anywhere from 7 to 28 day durations while in microgravity. On the tissue chip side, we working with a number of tissue chip NIH, NCATS tissue chip customers from including Emulate, the University of Florida, and UPenn, and flew our first batch of those systems back in May on SpaceX 17. And so these are the most complex ones we're working with due to the environmental control and everything else like that, but we've worked great with those teams to shrink down this complex biology into these cube labs, and you can see those kind of shown across in the photos there. This one is the most recent, some brain organoid studies that are on space station right now. They're coming home next week. We did 2 studies, one with the University of California, San Diego, that was a neurodevelopmental study using brain organoids, and another with the National Stem Cell Foundation that was neurodegenerative, looking at Parkinson's and multiple sclerosis. Again, complex in the sense of requiring tight temperature control, obviously the sterility and the imaging, but you can see from kind of top to bottom the assembly of the brain organoid study, the happy customers right before turnover down at the Kennedy Space Center about 3 weeks ago, and then looking at those brain organoids, checking the health of them before they're integrated into the cube labs themselves. We've done some work with flow chemistry. The one you see here was with Zyput Flow Technologies out of Boston. We're doing another system slated to fly in Q1 of 2020, looking at some flow reactions, some certain flow reactions. Again, still trying to take a kind of a desktop experiment and shrinking it down into an automated system, which we really see as our core competency. And so working on this with a few more coming down the line. This is really, as we think about doing science and then transferring that into potential manufacturing use cases, we see 3 different phases. And so there's material work, there's layer deposition work, and then there's biologics in terms of the scalable manufacturing. And we're working with customers in all 3 of these areas. And so this kind of shows some work that we did with FOMS, a group called FOMS out of San Diego, who were looking to build fiber optic cable on orbit. They built the hardware, and we served as a payload integrator for them using the microgravity science glove box, the MSG. You can see these photos from that experiment just a few weeks ago, or a few months ago. Our layer deposition work, so kind of the second phase, was some work we did with Lambda Vision out of Farmington, Connecticut. You can see this is some test footage on the top of our layer deposition design that we came up with them, and really just an interesting use case for microgravity in the sense that this is a product, this is a technology that requires microgravity for the even layer deposition. This is something we did back in December of 2018 on SpaceX 16. And then for us as a company, we're really looking for, using the space station for many, many years, but then moving what's next after the space station. And so what we really think about in terms of transferring some of that research to scalable manufacturing is what we call the FC42, but it's this concept. It's really a factory with a heat shield. It's this, approximately 10-foot diameter reentry capsule design that will take up raw material, build product of any of those stages of commercialization you saw, and then bring it back down. So with that, a lot of information there about SpaceTango, about our motivation, how we do things. If you have any questions, again, my name is Twyman Clements. If any questions, reach out to us at our info email address to see how we might be able to work together. So thank you very much.